Okay, what I decided to do here is actually record some extra examples for you guys on arc length and do it instead of with a PDF file. I'm going to do this obviously here with a movie file for you guys, and I'll upload it. But we have some really good examples, and the reason I wanted to do this particular way is so I could talk about these, and it's a little bit clearer. So we're going to look at a curve here. 1/4 x squared minus 1/2 the natural log of x. And we're going to look at this from 1 to 2. So here's some of the additional examples I promised you guys that I would do for you. And now let's take a look at the graph here, right? So this morning we had a nice graph. We don't want that one anymore. And we want the one we just looked at. So it's 1 divided by 4. Okay, get out of there. 1/4 x squared and divide by 2. Get out of there. And we have the natural log. So we're going to need some functions here. And let's put that x. Alrighty. So this is what we're looking at, and we want to go from 1 to 2. So let's see. I think we want to share this. Yeah. No. Oh, we want to, yeah. We want to copy this here. Okay, so we're going to go to Device, More, get a screenshot. I'm going to edit this here a bit. And to show you, we want to go from the value of x being 1 to 2. All right, so let's find that here on the curve here. So we're going to use this nice point. This is where x is 1. Here's where x is 2. And we're going to draw from 1 to 2. And we want to have find that value for s. That's kind of a weird. Looks like it's a crayon or something. I don't know. Maybe we'll see what we could do to fix that in the future. And so here's a picture of the curve with the potential. We're going from point 1 to point 2, or x is 1, right, to x is 2. Here's the 2 coordinates. Let's find the arc length. All right. So arc length formula. We're going to go from 1 to 2. 1 plus 1 y prime squared here. This is what we're going to use. So obviously, again, we really need all of this information under a radical. So let's get to work here, and let's find that derivative. Properties of derivatives. All right, here we go. This is going to be 2x, and this is 1 over x. So we get 1/4 times that 2x minus 1 over 2x, and your derivative is going to become 1/2 x minus 1 over 2x. All right. That's your first derivative, and I'm going to say keep this in mind. All right. So now we need to square this. So we square this particular derivative. And what this gives us is 1/2 x minus 1 over 2x. 1/2 x minus 1 over 2x. Right? FOIL. 1/4 x squared. That's the first terms. The outer terms is minus 1/4. In other words, if I multiply these two terms, I should get just a minus 1/4. The x terms cancel. Now the inner terms, right? So let's go back a bit. You guys know FOIL. First terms, got 1/2 or 1/4 x squared. Sorry. Outer terms. One half, you can think of this one as just x over 2 times that negative 1 over 2x. So we get really negative 1/4. So you guys know that algebra. The I terms, the inner terms, right? These terms here. We're going to get another minus 1/4. And then the last terms, we get 1 over 4x squared. So let me just clean it up. And remind you all that we have first, outer, inner, last by FOIL. So when we go to simplify, 1/4 x squared, really minus 1/2 plus 1/4 x squared. Okay. Now you say to me, this is our derivative squared. We need to add 1 to this. So we say 1 plus that y prime squared becomes 1 plus 1/4 x squared minus 1/2 plus 1 over 4x squared. And then doing my arithmetic here, because 1 really becomes 2 over 2. So we'll have 1/2 plus 1/4 x squared plus 1 over 4x squared. Now, students say, okay, I see this is what we get. And then they say, but you asked me to take the square root of this? And I say yes. But I'm going to write it a little differently. I'll put 1/4 x squared. I'm going to put 1/2 in the middle for a very good reason. So this is what we have under our integrand. And then you say to people, you're supposed to get arc length, right? Go from 1 to 2. The square root of this. 1/4 x squared plus 1/2 plus 1 over 4x squared. And then that's a dx here. So this is all under the radical. And then what happens with this particular example, students say, but Mr. Judge, boy, how do we integrate this, right? Since what's under this radical here is something we may not have seen before. Here's what I'm saying to you. Right? How do we integrate all of this here? Right? How do we work with that under a radical? So this is one of the reasons why I wanted to go over some of these questions, is because when you just read through it straightforward, you miss some things, I think, sometimes. So here's a remark I want to say to you guys here. Yeah. What is this under the radical? Okay, what is this exactly? If I go over here, I'm going to ask you guys, notice something looks very similar. The only difference here is the sign. There's a negative sign, and then the one down here, we have a positive sign. So it's not the same. It's slightly different. But let me ask you, how did we get this one, right? Where did this particular right side come from? And it came from up here. In other words, what this is really is 1/2 x minus 1 over 2x, and that's to the second power. You say, how do I know? Because this is where it came from. Is that right? Right? You guys notice the sign right here? That's where it came from. There's a minus sign. So what this means is that's a very big hint, ladies and gentlemen. If you can factor, and you can, this is really 1/2 x plus 1 over 2x to the second power. That's what's under this radical, okay? Now, this happens a lot with some of these arc length questions, okay? This kind of pattern that you see, this symmetry that you see here, where you have squaring a derivative that you see up here, right? And then down here, the sign's going to be opposite. So this now is very nice, because what this means is under the radical, you really have 1/2 x plus 1 over 2x to the second power. And what this means is you have the absolute value. That's the definition of the absolute value. And then you know, well, what about what's under, or what's here in between? Well, since we're integrating, or I should say this is defined for, we're integrating from 1 to 2, right? This function is defined for these values. It's continuous for x values between 1 and 2. So what you may notice is for these values of x, 1/2 x plus 1 over 2x is actually positive. And that's important, because what that means is, since this is all, let me write it down here. Since this is my integrand, all I have to do is remove the absolute value sign, because this is a positive term. And that happens with some of these here. So you guys know they're all specially chosen, so this works out, okay? So notice this, 1/2 x plus 1 over 2x is positive, so the absolute value sign goes away. Now we can integrate, and that's the idea here. All right, so now we integrate. And of course, well, whatever that was. Oh, let me double check what that is. Oh, that's my phone. So let me turn down my phone so you guys don't hear that, okay? I got a notification. Ooh, a man with a rifle, 1.5 miles away. And they got some, let's see if they got some video. Oh, they just got video of the police. Looks like he's around a dentist. Anyway, I'm looking at an app so you guys know. All right, whatever. Okay, Citizen app just notified me. Whew. All right. I think I'd just rather integrate. So let's do that. Let's look at this this problem here. Okay, properties of integration again. I have 1/2 the integral x dx plus 1/2 the integral of 1 over x dx, right? And of course, these are from 1 to 2, but let's integrate. X, natural log absolute value of x. But for the values of x, the absolute value is going to go away here. X is 1, x is 2. Okay, so this is what we get. 1/2 x plus 1/2 natural log absolute value of x here. So let me double check. Is this what we get? Oh, no, we don't. We don't get this. Guess we make mistakes in the afternoon too. This is what we get. And this is 4. Okay, evaluate this from x is 1, x is 2. So let's do some arithmetic. We get 1/4, 2 squared plus 1/2, natural log absolute value of 2, minus 1/4, 1 squared plus 1/2, natural log absolute value of 1. This is 0, and this is just natural log of 2. And let's not forget, 2 squared here is 4, so we're going to get a nice 1 here. So we have 1 plus 1/2, natural log of 2, really minus 1/4, and we're going to have to add fractions here. Okay, so 1/4, 4/4 minus 1/4 gives us 3/4 minus or plus 1/2 natural log 2. So ladies and gentlemen, here's another example of arc length. And I can make a quick remark here that sometimes you can say, isn't this really by properties of logs? Natural log of 2 to the 1/2, or simply natural log of the square root of 2. And yeah, you can replace that with, natural log square root of 2 if you like. So, right. So here's an optional answer. Anyway, you guys may be used to these nice boxes, right? So there you go. And that's a pretty good example. So that's something, I have a bunch of examples here. Show you how things kind of work sometimes. Anyway, let's look at a few more here. Let me give you one that's very similar, to illustrate my point. But we have here x now equals 1/8 y to the 4th plus 1 over 4y squared. Now, this is good from y being 1 to 2. Okay, so we're going to try this one out as well. Now, let's go to our graphing software and let's see if we can actually graph this one too, right? So they're going to give us here now x equals 1/8 y to the 4th. So 1 divided by 8, get out of there, y raised to the 4th power. Looks like it's going to work. Get out of that position, plus 1 over 4y squared. So 1 divided by parentheses 4y to the 2nd power, close the parentheses. There we go. And let's check to see if this is really what we have. Okay, yeah. All right. Now, let me get closer here. Okay, here's this curve. We got a weird issue here. I believe there is going to be additional information. Let me tell you guys something here. Okay, so there's going to be additional information on this. Let's go to the iPad here. Right, y, well, there's no additional information. We know y goes from 1 to 2 here. So here's what I want to say. So since y goes to 1 to 2, let's get this graph, get a hold of this. And let's find out where this is, right? Here's 2. Here's 1. Right? This is y is 2. Y is 1. We're out of space there. So we're going to want to sketch from here to here. Right? Here's the points. Maybe we should change that color. So from y is 1 to 2, this is our curve. This is what we want to find. This is the arc length S we're looking for. Okay, so anyway, just to kind of let you guys know, I don't want to save that. All right. But if we can find our notes, let's remember something here that we talked about earlier. And by the way, I did fix the typo. The typo was a phrase down here after we proved this. Yeah, this is the proof of the arc length formula. Okay, so the following is the proof of the arc length formula. And I remarked at the end of lecture that we also can have a function where x is g of y here. This is what we're looking at now. So we're going to look at how to handle this situation where y is between c and d. Okay, so this is what we were given now in this example. All right, let's kind of look at that. This is nice. So I want you guys to notice that this is what they gave us here for this, okay? So we're going to try this out. But remember, we need dx dy here. Okay, we need dx dy, not dy dx. So here is what we use here. Arc length formula. This is c to d. This is for the y, right? So y is c, y is d. It's analogous. 1 plus dx dy squared, and then this will be a dy now. Okay, because what they gave us here is x being a function of g, and c to d there is our interval for y. All right, we need to do the derivative work here. So dx dy becomes d dy 1/8 y to the 4th plus 1/5 4y squared. Properties of derivatives. So differentiate. This becomes 4y cubed. Well, this is y to the minus 2, which means we have minus 2y to the minus 3 here if we differentiate. So we get 4y cubed over 8 plus 1/4 times a negative 2. Let's actually write this as negative 2 over y cubed. So we get this dx dy 1/2 y cubed minus 1 over 2y cubed. All right, this is what we get. 1/2 y cubed minus 1/2, okay. And then you say, well, I'm supposed to square this, right? So keep an eye on the pattern that happens here. Square that. 1/2 y cubed minus 1 over 2y cubed. Square this. 1 over 2y cubed minus 1 over, I know it sounds like it's the same term, but it's not. All right, you guys okay with that one? We're going to multiply this together. And again, we're going to use what here? FOIL. Use FOIL. 1/4 y to the 6th, first term. Outer terms, minus 1/4. Inner term, That looks like it's also minus 1/4. And then the last term, 1 over 4y to the 6. Now, combine like terms. This is 1/4. We get 2/4, which is 1/2, plus 1 over 4, y to the 6. So we squared it. Now you say, aren't I supposed to add 1? You are. And when you add 1, we have 1 minus 1/2 is a positive 1/2. So you guys know, but you know where I'm going to put this. I'm going to put this in the middle. And you say, I don't recognize this. Well, yes, you do. I know there's a plus sign here. This looks familiar. Where have I seen something like this? We've seen it right here. See this? But the sign is opposite. And you say, where do we get that? We got that by squaring dx dy. So that's a negative sign. Okay, that's going to change here for us. So here's what I'm saying here. When you factor this, you get 1/2 y cubed plus 1 over 2y cubed. This is a perfect square trinomial, ladies and gentlemen. Factor that. This is the factored version. Right, we factored this. I'm going to say here, factor this. And it's a perfect square. And you say, well, does that help me? Absolutely it does, because don't forget, we really have to take the square root now. Let's try to do this here. Square root of 1 plus dx dy squared becomes the square root of 1/2 y cubed plus 1 over 2y cubed squared, which is the absolute value of 1/2 y cubed plus 1 over 2y cubed. Now you say, what is this good for? It's good for y between 1 and 2. Why is that important? Because the absolute value is positive. I can get rid of my absolute value sign, right? I'll put it right here. I'll say it over here. We're going to put this here. Right? 1/2 y cubed plus 1 over 2y cubed is positive for the y values that they gave us. That's why we can get rid of it. And that's why it's a good thing. So I want to say there's some symmetry here that I talked about. We can factor that. It's a perfect square trinomial. It becomes the absolute value, and what's inside is positive. And that's good. Now we can integrate, because we're going to integrate from y is 1 to 2. 1/2 y cubed plus 1 over 2y cubed. And that's dy. So as you can see, I was right. There was some very, very similar, it's a similar question. It's analogous, but the variables are different. Okay, in the first case, you had y as a function of x. In the second case, you got x as a function of y. And so by properties of integrals, right, we can say this is, I don't know, it's kind of weird. It's like kind of walking on a crack. We can break our back. Those old wives' tales. Y cubed dy plus 1 over 2 integral 1 over y cubed dy this time here. All right, let's double check that we have the right information. Yeah, looks good. Okay. We're integrating. Remember, this is y to the minus 3, so that gives us negative 2 over negative 2, right? Let's do the algebra. One half, 1/4 y to the 4th plus 1/2. And that's going to be minus 1/2. Or minus, yeah, that's going to be minus 1 over 2 with that y squared. It's on the bottom now, and we got the 1/2. Okay, this is going to give us 1/8 y to the 4th minus 1 over 4 y squared. We evaluate this from y is 1 to y is 2. Okay, let's plug in the limits here. 1/8, 2 to the 4th, minus 1/4 times 2 squared, minus 1/8, 1 to the 4th, minus 1 over 4, 1 squared, right? Here's what we're doing. 2 to the 4th. I think that's 16. Minus 2 squared there is 4, so I get a minus 1 over 16. And then we get minus 1/8 plus 1/4. And 16 over 8 becomes 2. So I have all this arithmetic to do, as you guys can see. Right, 2 minus 1/6 minus 1/8 plus 1/4. So we're going to have some arithmetic, and I'm going to say to you guys, what should we do? How do we add this here? If you guys know, I'm going to do something here. The denominator, the LCM here is 16. So multiply this by 2 and this by 2. Multiply that by 4, this by 4. And that's 16 over 16, right? Our denominator is going to be 16 here. So I get 32 minus 1. I guess you might want to see every detail. 32 over 16 minus 1 over 16 minus 2 over 16 plus 4 over 16. They're all over 16, so I get 32 now. Minus 1, minus 2, plus 4. Everything over 16. So we're going to get our arc length to be, 32. It looks like it's going to be 33 over 16. Notice that's a nice positive number, ladies and gentlemen. We talked about this in the lecture. Your arc length is going to be positive. It doesn't matter if the curve is below the x-axis or above the x-axis. Distance traveled is always positive. That's a nice positive number. So here's a nice example that's very similar to the first one, and this is what I wanted to show people, this kind of pattern that creeps up with arc length. And let's take a look at the next one. The next one's kind of interesting as well, I guess. We got y is natural log 1 minus x squared. We're going to look at this from 0 to 1/2, okay? So as you guys know, I like to look at the graph. Got to be careful with this water I have. All right, let's look at the graph. Okay, so what do we have here? Y equals, we need some functions. Natural log of 1 minus x squared. That's a good one to look at. Okay. They're going to say, let's go to the device. We're going to take a screenshot of this. That's not what I wanted to do. I wanted to resize. There we go. Okay. I want to look at this way, and, you know, I'm going to kind of double check here. Let's kind of play with this here. I know, well, let's change the color there of these points. We're looking at 0. This is where x is 0 to 1. I'm sorry, that's not the point, but that's the point for the first one. But when x is 1/2, you guys can see, here's that next point, okay? Now, I'm not so, I think I want to do something like that. Actually, I don't. Maybe this? That looks just a little better. And I made that a little bit, I reduced the opacity on that. So that's a bit better. And now this is the arc length. This is what we're looking for. This is x is 0. Remember this? And this line is x is 1/2. So we can see this curve, what we're trying to do. And look, it's below the x-axis, but like I mentioned before, the distance traveled, right? You're walking on this thing. The distance traveled, ladies and gentlemen, the distance you walk here is going to be a positive distance the second you move. So, okay, that's a nice curve. Let's go with the process. Now, the arc length formula. Integrate from 0 to 1/2. 1 plus dy dx squared dx. We need dy dx, so differentiate. Natural log 1 minus x squared, okay? And here, of course, you're going to use chain rule, which would be 1 over 1 minus x squared times the derivative of 1 minus x squared. And this is by chain rule. So remind you guys, things like derivatives and chain rule just never go away. This stuff doesn't go away. And that's minus 2x. So this derivative is, I'll write it that way, negative 2x over 1 minus x squared. That's our derivative. Okay, good. And you say, we're supposed to square this. And when we do, we get dy dx squared. Square that, we get a positive 4x squared. Okay, and over 1 minus x squared squared. Yeah, that looks okay. Looks like we're on the right track. All right. We need 1 plus dy dx squared, which is 1 plus 4x squared. All right, here's we're going to do some algebra here. And you might not be able to see this. I'm going to erase this here because I need some space. Be a good idea. I'm going to say we're going to put this as 1 minus x squared squared over 1 minus x squared squared because we need the same denominator if we're going to add, right? Okay, so we get 1 minus x squared squared plus 4x squared, everything over 1 minus x squared squared. So we look at this here, and we say to ourselves, well, how are we going to proceed with this? What are we going to do now with this stuff, right? As you guys can probably guess, what comes next is you're going to FOIL here. In other words, I need to simplify my numerator. So what that will mean is 1 minus x squared times 1 minus x squared. This is the FOIL I'm talking about. After I FOIL, I add a 4x squared. That's over the denominator. So by FOIL, I get 1 minus 2x squared plus x to the 4th plus 4x squared, right? I FOILed over here. And this is all over 1 minus x squared squared. Now, when I combine like terms, you say you get 1. What do we get? Let's be careful here, right? Which terms can we combine? Can you guys see that? This term and this term. So I'm going to get a negative 2x squared plus 4x squared is a positive 2x squared plus x to the fourth. Everything over 1 minus x squared squared. Now I'm going to remind you guys, this can be factored, my numerator. This should look familiar. We got 1 plus 2x squared plus x to the fourth, right? This can be factored. It's a perfect square trinomial as 1 plus x squared squared over 1 minus x squared squared. This is the numerator here. This is, we can factor that. Let's double check, yeah. Okay, so the numerator is factorable as a perfect square trinomial. Let me make sure that 2 is nicer. All right, now you said this is 1 plus that derivative squared. Aren't I supposed to take the square root? You are. So we have the square root of 1 plus dy dx squared becomes the square root of, let's make that nice and bigger. 1 plus x squared squared over 1 minus x squared squared. And that's actually too big. And as you guys can guess, this starts to become really 1 plus x squared over 1 minus x squared squared, which is the definition of absolute value of 1 plus x squared over 1 minus x squared in absolute value. This is good for 0 to 1/2, I believe, right? And I want you guys to notice something here. The numerator is going to be positive. The denominator, because you have 1 minus x squared down here, right? If I plug in x is 0, 1 minus 0 squared is 1, and that's a positive number there. If I plug in for x a 1/2 now, I get 1 minus 1/4. So my point is, for all these values of x, the denominator is positive. My numerator is already positive. What am I really saying here? What I'm really saying is 1 plus x squared over 1 minus x squared is positive for the values of x that we're looking at. So we get 1 plus x squared over 1 minus x squared. Good. And you say, oh, I guess I have to integrate this, right? Yes, you do. And I think we're going from 0 to 1/2, right? 1 plus x squared over 1 minus x squared. We're supposed to integrate this. And that's going to be a dx. Okay. So the question is going to be now, how can we integrate this? You're going to say, oh, that's a big headache, right? And even if I get rid of these, how do I integrate it? Well, I want you guys to remember something here. When you have the same power, you can divide. Right? You got the degree of the numerator is the same as the degree of the denominator, so we can do some division here. So let me show you a nice little trick about division. So if you go back to, oh, I don't know. What class is that? Beginning algebra or, pre-algebra. I can divide here, right? Remember this? X squared over minus x squared will be -1. That -1 goes above the constant term. Now multiply the -1 times this negative x squared plus 1, and we get positive x squared minus 1. Subtract now. Use your division algorithm, which really means change those signs, right? and we bring down the 0x, and we get a 2 here. Now, that 0x is really 0. We put it as a placeholder here, right? So when we did our division. So we actually divided. Here's my quotient. Here's my remainder. This is what we divided by. So this is equal to, if you guys remember from, I don't know, algebra, 1 plus 2 over the, well, we wrote it as negative x squared plus 1, but we can write it the way it was originally given. So what we really have to do is integrate this particular function from 0 to 1/2 to get our arc length. And again, by properties of integrals, minus integral dx plus 2 integral 1 over 1 minus x squared dx. And they're both going to be from 0 to 1/2. Okay? So I want to note something here for you guys. There's a different ways we can do this, but I want you guys to notice something here. This first integral is easy. That's minus x. But the question's going to be, right? How do I integrate 1 over 1 minus x squared dx? There's a couple of ways we can do that. I'm going to say, if we consider a over 1 plus x plus b over 1 minus x, you might say, where are we going with this? What was that procedure? Partial fraction decomposition. So, you know, you guys did have a test on this kind of stuff, and the reason you guys had a test on this stuff is exactly because you're going to use this. Okay? So that's kind of why, you know, we have that for you guys. And you might say, oh, can you continue the process? Well, what did this stuff mean? Remember this? This is going to be what? 1 equals a times 1 minus x plus b times 1 plus x. Right? We got this characteristic equation. Well, if x is 1, you say, what does that mean when x is 1? We get 1 is b times 1 plus 1. Or that means 2b is 1. We found the value of b being 1/2. So b, you're positive 1/2. And if b is positive 1/2, we say, well, how do we get a? Well, let's try to get a then. We're going to say, let x be negative 1 now. When x is negative 1, we get 1 equals a times 1 minus a negative 1. And this is going to be, since x is negative 1, remember out here, we get this term being 0. So we're plugging in that negative 1 everywhere there's an x. What does this give us? 1 equals 2a, or a equals 1/2. So you have the terms here. Now let's double check here. I want to double check my work. We said first x is 1. We get 2b. What do we get here? Let's be very careful. A times, this is 1 equals a times 1 minus x plus b times 1 plus x. X is positive 1. We get the a term being 0. And we get 2b is 1. So b is 1/2. Now x is negative 1. B is 0. 2a is 1/2. Okay. All right. Is that what we get? So they're both 1/2. All right, looks like that's the case. We get 1/2 minus 1/2 x. All right. So let's write this down. We have to integrate now. One half over plus 1/2 over. That's 1 plus x and 1 minus x. So let's remember, just checking this. Looks like we're good. Oh. I don't know why I always thought 1 would be negative. Okay, here we go. We're going to use properties of integrals. So we get 1/2 integral 1 plus x dx plus 1/2 the integral of 1 over 1 minus x dx. Okay, so we're going to use properties of integrals here. Now, the first integral we know is natural log absolute value 1 plus x. However, the second integral, we have to use u sub, where u is 1 minus x. Then we get du dx will be negative 1 r dx is simply minus du. So this integral here becomes 1 over u times negative du, or simply minus the integral 1 over u du, which is minus natural log absolute value of u, which becomes minus natural log absolute value of 1 minus x, because that's what u is. So let's put this all together here as this integral, right? We have 1/2 natural log absolute value of 1 plus x. This is now going to be minus 1/2 natural log absolute value 1 minus x, because of the fact that down here we got a minus, right? A minus sign. So altogether, I just want you guys to note, here's a fact. Let's put it down here. That the integral of 1 over 1 minus x squared dx becomes, it's right up here, factor out the 1/2. Natural log absolute value 1 plus x minus natural log 1 minus x. We said factor it out. Natural log 1 plus x over 1 minus x. So that's the integral. This is what we're going to end up using. So I want to let you guys know this integral sometimes shows up. That's why I'm writing this as a note. Anyway, okay. So here we go. Let's put this all together. Don't forget. This is where we're going back to. So my arc length formula here, what we've seen here becomes negative x plus 2 times 1/2 natural log 1 plus x over 1 minus x. And this is good from 0 to 1/2 again. So this is going to be negative 1/2. And don't forget this 2. We can simplify this here. Let's simplify it first. Negative x plus natural log absolute value 1 plus x over 1 minus x. X is 0. X is 1/2. So we get negative 1/2 plus natural log 1 plus 1/2, 1 minus 1/2, minus a negative 0 plus natural log 1 plus 0, 1 minus 0. I want to point out to you guys that this portion here is going to be the natural log of 1, which is 0. So altogether, negative 1/2 plus the natural log of 1 plus 1/2 gives you 3/2. 1 minus 1/2 gives you 1/2. And 3/2 minus 1/2 is actually 3. So this portion here becomes natural log 3. And so here's my arc length. It's the natural log 3 minus 1/2. And so here's yet another example. And by the way, this is a positive answer. And let's make sure this looks like a natural log. And this is how we work with this result. Okay, let's maybe do one more. Yeah, let's do something like this. It's kind of interesting here. They're going to give you an example here. They give you this relation. Y squared equals 4x. And they say 0 is less than or equal to y, which is less than or equal to 2. Okay? So as you guys know, if we go to our trusty graph here, okay, and we need a keyboard. All right, let's try to take a look at this. So there's a couple of ways I could do here. Yeah, anyway, that part. Let's go back to the iPad. Here we go. We got to put y squared. Y squared equals 4x. Here's my relation here. And let's change the color. So if I go to settings, here we go. And let's remember y goes from 0 to 2. So I'm going to do this here. And let's mark here. This is y. Y goes to 0 to 2. So this is y is 0. Right? We got this line y is 2. And I guess that's a crayon. All right, now that's why it looks so weird. So 0 to 2. Notice we're asking for this distance here. So the points we're looking for is here to here. These are y values. This is my arc length. This is the S we're looking for. Okay. You want to know what that distance is. All right. And I want to remark here, we're going to use this form here. So because they gave us these y values, this is from C to D, we need to write x as a function of y. And that can be done because if we have y squared is 4x, if we just divide both sides by 4, we get x squared, or x is y squared over 4. So this is all good to go. All right. So I wanted to just show you guys that. Okay. So in this case, right, the arc length formula is going to be from C to D. This is for y now. Let's do every detail. So we know what x is. This means dx dy is the derivative with respect to y squared over 4, 1/4. 1/4 times 2y, which is y over 2. Okay, so here we go. Dx dy is y over 2. We're going to square this. And we end up with dx dy squared becomes y squared over 4. So 1 plus dx dy squared becomes 1 plus y squared over 4. And so you can say we have to integrate from 0 to 2 square root 1 plus y squared over 4 dy. Now, of course, at this point, you might say, don't we have to do some simplification here? Yeah, we have to add, right? So 1, and I'll put that in blue. 1 plus y squared over 4. Remember, we're going to have to add with the same denominator. So you get 4 over 4. Y squared over 4. 4 plus y squared over 4, and this is all under my radical here. So the arc length here, or if I just, let's just write it all out. And you guys know what happens up here, right? Square root 4 plus y squared over the square root of 4, which is the square root. 4 plus y squared, everything over 2. Arc length, 0 to 2. Square root 4 plus y squared divided by 2 dy. And really pull out the constant 0 to y, square root 4 plus y squared dy. Okay. All of that work, all of this algebra, and this should be 0 to 2. All of this algebra to get down to this integral and to say to you, I'm going to put this in a box. Oh, nice. Here's the box. We got to integrate this. So here's the big question now. How can we integrate that function? And at this point, you guys should know the answer because you just had a test on this. What you use is trig substitution. Okay, so by trig sub, you let y be 2 tangent theta. And what that means is dy is derivative of tangent is secant squared theta, right? D theta. And then your radical, 4 plus y squared. If you guys remember, that radical gets replaced with 2 secant theta. So this is using trig sub for this integral. And I'll put it here in red so we know. And I'm not going to put my limits here. Okay, I could, but I'm going to leave them out for now. So I know I have here the square root of, in blue, maybe we'll do that way. Doing the trig sub. And maybe I'm going to pull along my constant all the way through. Maybe that'll help us, okay? Let's pull that out with us. That square root. Oh. the square root of 4 plus y squared is really 2 secant theta. So I use this portion. What is dy? Well, that's 2 secant squared theta. So that's another 2 secant squared theta d theta. So I'm glad I'm bringing down my constant now. I'm going to bring this down so you guys know. Okay. So what that does for us is we end up with 2 secant cubed theta d theta. And we have to integrate this. Now, like on your test, I remarked to you guys that you should know some of these integrals because they pop up all the time when we study trig integrals. And this is one of them. You've seen it over and over again. So we want to know, well, what is this integral, right? Well, if you guys remember, this is 1/2. Let me see if I have some space. One half secant theta tangent theta plus natural log absolute value secant theta plus tangent theta. And don't forget that 2 gets multiplied to the whole thing. So you get cancellation. So your arc length now will be secant theta, tangent theta, natural log, secant theta, plus tangent. But we evaluate this from y is 0 to y is, what was that? 0 to 2, yeah. But that's y, that's not theta. So as you guys know, we have to go all the way back. We have to find out, we got to convert this, right? This is secant theta. And what do we know? Y is 2 tangent theta. So what that means is tangent theta is y over 2. Tangent is opposite over adjacent. Hypotenuse would be 4 plus y squared. So I have tangent theta. I have this value. I have this value. We need to know what secant theta is. Secant theta, remember, is the reciprocal of cosine. Cosine theta is adjacent over hypotenuse. So this will be hypotenuse over the adjacent side. Okay? So let's write this down. What do we really have here? Okay? For the arc length, we have square root 4 plus y squared over 2. That's my secant theta. Tangent theta is y over 2. Plus natural log, absolute value, secant theta, square root 4 plus y squared over 2 plus what's tangent theta going to be? Well, that's y over 2. And that's an absolute value. For y is 0 to y is 2. So my arc length here is y square root 4 plus y squared over 4 plus natural log absolute value 4 plus y squared over 2 plus y over 2. And we're going to evaluate this from y equals 0 to y is 2. So double check. Hopefully we're not making any mistakes. So the first y value, we're going to have 2 square root 4 plus 2 squared, everything over 4. Plus the natural log, absolute value, square root 4 plus 2 squared. This is over 2 plus 2 over 2 minus y is 0. 0. Square root of 4 plus y squared over 4 plus the natural log, absolute value, square root 4 plus 0 squared over 2 plus 0 over 2 here. So let's quickly check we're not making any mistakes. Okay, let's try to simplify this. That 0, that is 0 here. There's a 0 here, sorry. This here is 1. Okay. And let me make sure. All right, this is absolute value here. All right, let's see if we have some nice value here. 2 square root of, looks like it's 8 over 4 plus natural log, absolute value again, square root of 8 here, but this is over 2 plus 1. And then we have minus natural log, absolute value, square root of 4. Look at this. This is square root of 4 over 2. Okay. Because we're focusing on this. So that's 2 over 2, which is 1. So this portion here, so you guys know, is 0. That's gone. So we have an arc length here of the square root of 8 now over 2 if we simplify here. Plus natural log, absolute value of square root of 8 over 2 plus 1 here. Now let's do some simplification here. If you guys know, the square root of 8 is the square root of 4 times 2, which is 2 square root of 2. And so our arc length becomes 2 square root of 2 over 2. Natural log, absolute value, 2 square root of 2 over 2 plus 1. So I get the square root of 2 plus natural log, square root of 2 plus 1. And because the value inside the absolute value sign is positive. Okay, let me double check my notes to see if I'm correct. Yeah, square root of 2 plus natural log, square root of 2 plus 1. Anyway, okay. Here's the extra examples I promised you guys, and so I hope you guys enjoy. All right, there you guys go.